All right, so I'm just making a video of the questions from the Unit 4 review. So solve exactly the equation given for x. This means they want it as an exact answer. So you're going to rewrite it as a logarithm. And you want to put that log in parentheses because you're going to work around it. You're going to add 6 to both sides. And then divide both sides by 4. So this is the exact answer they're looking for. All right, convert to exponent or convert to logarithm. So start with log. That's your base. Loop around, that's your argument. Loop around, that's what it equals. Okay, you can start with log. That's your base. Loop around, that's your argument. That's a lie. That's your base. Now, when base 10, you don't need to write the little base right here. Okay, loop around. And then loop around. Okay, solve exactly. You're going to rewrite it as an exponential. So base, loop, exponent, loop, equals. So add 1, divide by 5. Write as a single logarithm. So the one thing you have to watch out for with these things is parentheses. Inside parentheses first. So order of operations as you take care of that. And addition is multiplication. Exponents become coefficients, or coefficients become exponents. And then subtraction is division. Okay, first thing I'm gonna do on this one is fix that so that it's an exponent. Think exponent over index. And then that multiplication, that's addition. And then each of these exponents, they become coefficients. All right, find the time required for an investment of $5,000 to grow to $6,400 at an interest rate of 7.5%, compounded quarterly. Okay, so I'm going to take you back to those notes in 4.5. Compounded quarterly. It's this formula here. Okay, so we know 64. Principal is 5,000. Compounded quarterly. So it is rate over number of times compounded. So 0.075 compounded quarterly, all to the NT, I think. Yep. So 4t. All right, so first thing I'm gonna do is I'm gonna divide by 5,000. And when I divide by 5,000, I'm gonna cancel my zeros, but I'm gonna leave the 64 over 50. And then I'm gonna work this out. I'm gonna take the log of both sides. Exponents become coefficients. Divide by the log. So I'm only going to write it once because I'm being very lazy. And then I'm going to divide by 4. Which, just for the sake of space, I'm going to multiply by 1/4, just because that's a little closer. So what I'm going to do, I'm going to do this in my own calculator first and show you how I do it, just so I can have the answer here. So log okay, so the answer is 3.32 years. Now I'm going to show you how I would do this in my calculator, because entering all that in can get a little special. So remember, this is an emulator. All right, so I'm going to do my fraction. Then I'm going to do log and fraction again. 64 over 50. And then do log 1.01875. Make sure you actually put 50 instead of 5. All right, and then I multiply that by 1/4. So 3.32 years. Okay, half-life of strontium. Okay, so half-life is negative ln of 2 over k. And it tells me that's 28 years. How long will it take for 52 milligrams sample to decay to 13? So we need the k first. So 28 equals negative ln of 2 over k. So 28k equals the negative ln of 2, which means k equals the negative ln of 2 over 28. And we're going to use this formula. By the way, half-life is in these notes too. So I'm using that formula. So I want it to decay to 13. It starts with 52, and the k, negative ln of 2 over 28, and we're looking for time. All right, so I'm going to divide by 52 first. I'm going to raise both sides and take the ln of both sides. When you take an ln, it cancels the e. And then I'm going to divide by the negative ln of 2 over 28. Use your fraction, ln of 0.25, negative ln of 2 over 28. So 56 years. Okay, this one's asking about doubling bacteria. And doubling is the positive ln of 2 over k. And we know that it is 15 minutes. Which means 15k equals the ln of 2. So k equals ln of 2 over 15. So at time 120, bacterial population was 60,000. What was the initial population? All right. So, is it 60,000? We don't know A0. We know the K is the ln of 2 over 15. Oh, we know the time is 120. All right, so I'm basically going to divide by this E. All right, E to the ln of 2 over 15 times 120. The initial population, A0, was 234.375. And then what is the population after 5 hours? So time is in minutes, so 300 minutes. And now I know that the initial population is this. We can just plug in. Times E to the ln of 2 over 15 times 300. So 245,760,000 bacteria. All right, another pH problem, and that's going to go with your 4.5 notes, which was here. All right, so pH is 5.15. So I'm going to divide by that -1. Rewrite it in exponential, so the base is 10. Loop. All right, so we put that in the calculator. 10 to the -5.15 Get you that E thing. So 7.07945. Oh, 794. I think it was e to the -6. Yeah. So what this means is that this becomes the exponent. So it's 7.08 times 10 to the -6. All right, investment of 17,500, 16%, 16.7% annual interest compounded continuously. So this is my formula. And really, you're just plugging in that 17,500 is your initial. Your interest rate is 0.167, and your time is 43. So I'm typing it in my calculator. And let's see, to the nearest penny is 2 decimal places. It's a lot of money. All right, this question wants you to use the interest rate that's given, so 6%. Find the value of investment after 4 years for each of the following compounded methods. Use your answer to the nearest penny. So this is compounded, like quarterly, annually, semi-annually, whatever, and this one's continuously. So for annual, your N is 1. So principal rate is 0.06 divided by 1 times 4. That's straight calculator. All right, so after 4 years, compounded annually. And let's see, compounded semi-annually, so this is when N is 2. So effectively the same formula, just changing the N. So that's going to give me 42,000, that's like 44,210.28. So now I'm on this one, monthly, which means N is 12. And then continuously is this one. So you just need the right formulas for each of those. All right, so this one, they want you to choose the right equation for it. All right, this is a decay function. So that means your base is between 0 and 1. Because it's 3. That one, that one, or that one. So that eliminates half of my answers. All right. Now, your typical horizontal asymptote is here at 0. Our new one is at 2. So this graph has been shifted up 2 units. So that's going to give me that one. Okay, so draw the graph. I'm doing this on an iPad, so on your computer it'd be a little different. This is your first point's going to mark the horizontal asymptote. And then you give 2 points after that. Your parent graph, not the graph that's given, but your parent, has a horizontal asymptote at y equals 0. All right, the base is 4. You have 2 key points. You have one at 0, 1, and then one at 1, 4. All right, this is telling me that my new asymptote, which is what you're going to graph first, is going to be at -3. So when you click this on your computer, you'll click that first, and then each of these points is going to go down 3 units. So 1, 2, 3, 1, 2, 3. So you'll select those 2 points, and your program will graph that for you. Domain. All exponentials have the same domain. That's terrible infinity. Negative infinity, positive infinity. And your range is determined by the asymptote here. So -3 to infinity. And your horizontal asymptote is y equals -3. All right, so we have to transform this function into this one with this graph. Okay, the key thing that you want to see right away is that the horizontal asymptote is no longer at 0, it's at 4. All right. All right, and I do have a key point right here, and I'm going to use this key point because its x-coordinate is a 0. And why that's important is because I can plug them in. So y is at 1, x is 0, and I can use it to solve for a. So anything to the 0 power is 1, which means the a is -3. So y equals -3 times 2 to the x plus 4. Let's see, what would I do on this one? Probably rewrite it as a logarithm. Log base 2 of something equals log base 2 of 3. Okay, let me rewrite that. I'm rewriting it as a logarithm. So the first thing to do is write log. That's the base. I don't know what my argument is. Loop around. And so what I should see here is that these are effectively the same, which means that my question mark is 3. So we're going to do the same thing on this one. Log base 10 of a question mark equals log base 10 of 9. So log without a subscript and log with a subscript are the same. So my question mark is 9. So log base e of a question mark equals the ln of 5. Log base e represents ln. So my question mark is 5. Okay, you can do this in a couple different ways. All right, if you have the t at 84, okay, alpha, window, 5. Also use Desmos graphing, not Desmos scientific, use Desmos graphing. And you can type this in. Okay, if you use Desmos scientific, any other calculator, you have to use change of base. Common log, which is log 10 of the big number, divided by common log of the little number. I'm going to use alpha window 5 because it's quicker. and 4 decimal places. 9, 9. Okay, domain of a logarithm. Set your arguments greater than 0. So x has to be greater than -2. So this is -2 to infinity, and the solve exactly. This takes some work. All right, so you're not use your calculator on this one. All right, so the first thing I'm going to do is take the log of both sides. Then exponents become coefficients. Distribute. Distribute. You want your x's on one side and your non-x's on the other. So I'm going to subtract the 9x log 2. And I'm going to add the 9 log 3. All right, now, then we're going to divide. I'm not going to write it twice, but I'm going to divide by this. Okay, this is your exact answer. All right, when you are solving a logarithm, you end up in 2 different spots. Either log equals log or log equals number. This one falls under log equals number. All right, you have 2 logs on the left. You're going to go ahead and condense them. And subtraction is division. So we're going to divide the arguments. All right, this is a log base 10. So I'm going to rewrite it as an exponential. Loop around, that's your exponent. Cross multiply. Distribute. Subtract x. Subtract 40. Divide by 9. This is what it means by exact answer. All right, so this is the last question. Given the graph log base 2 of x. Okay, I didn't give you a graph, that's fine. The graph of f of x equals 3 plus log 2 of x can be obtained by shifting this graph which direction? This plus 3 means you have shifted the graph up 3 units. If it was inside, it would be left and right, but it's outside. Domain doesn't change. It's that guy greater than 0. Range doesn't change either. It's negative infinity to positive infinity.